Hi, and welcome to this episode. Here I will talk about gravity once again. It will be closely linked to a previous video I made about the rotation of the moon. Let's say that this is a central mass of some kind, and let's say that we have a smaller mass, which mass is almost neglectable compared to the main mass who's orbiting this main central mass. The orbital speed for this object in orbit will be proportional to 1 over the distance from the central mass. So that says, because it's proportional to 1 over the distance, so if it's close to central mass, it will move fast. If it's long away, it will move slower. This is a well-known fact, which says that, for example, a planet who's close to the sun is orbiting faster than a planet further away. Same as a satellite close to Earth is orbiting faster or with a faster orbital speed than a satellite further away. If you don't believe me, you can probably check this up, but this is a well-known fact, not that hard to test or to verify. Okay, so what happens with an object who is in a position with a too low or a too high orbital speed? That is also very easy. If it's too high, the orbital speed for this object is too high for the position where it is, it will then have too much energy, so it will move up in a higher orbit. Same as an object who has a too low orbital speed will fall down and then orbit at a lower orbit. Also well known and very easy to calculate. A little bit harder to verify, but we're quite sure that that's how the universe works. So back to the thing. If we, for example, have a central mass like this object will then orbit in the orbital speed of its central mass, which is in the middle of these two circles. Okay, but the idea here is that if we don't look this as one object, if we look this as separate objects, two objects like this, two different, this ball, this circle over here, will orbit in a too high orbital speed, because it will orbit in the orbital speed of the central mass, which is lower than this object. And as we said, an object which orbit in a too high orbital speed will move up. It will move upwards. The same thing goes for the circle below the central mass. It will orbit in a too slow orbit than the orbital speed for its position, so it would want to fall down. So an object that is a rigid object like this can of course not separate like this unless the gravity is really strong, but normally it's not, so rigid orbits continue being rigid. It's not torn apart normally. So this rigid object, for this part of the rigid object, it will want to go down here, and this one would go up here. And according to me, the only sensible way for this object to move is then of course here. And this will make the object, when it's in its orbit, if it's not rotating or anything, if it's moving or orbiting in normal, it will move over like this, because this part will want to try fall down to a closer orbit, and this one would try to fall up to a wider orbit, which will give the orbit an orbit where the same side points towards the central mass all the time, which is exactly as I talked about in my earlier video about the rotation of the moon, is not as how most people think about rigid objects in orbit. Yeah, that was all.